Hi everyone, this is Asma Mushtaq from the eevibes, and in this video lecture I'm going to explain what is the breadth-first search algorithm and how does it work. So basically the breadth-first search algorithm is used for the connected, directed or undirected graphs for finding the minimum path for visiting all the vertices starting from the source vertex. Alright. So in the breadth-first search algorithm we will be using the queue of the data structure for basically storing the elements, and we will see that the breadth first search algorithm basically involves the three steps. The first one is the in queue. In the in queue procedure, we will be entering the elements at the tail of the queue. All right, and we will be writing those vertices that have been visited from the graph in the queue. Fine. The second procedure is the dequeue step. Once all the neighbors of a particular source vertex have been explored or visited, we will dequeue them from the queue and output them. The last step is to make the queue empty. We will keep doing inqueuing and dequeuing procedure until all the vertices have been explored. So for understanding the concept, let's assume that the particular graph that I'm drawing over here. Okay, so here we will start with the empty queue, and we will consider the node 1 as the source vertex. Let me mark it with S, and we will in queue it because initially the queue was empty. So this one will be added in the queue. Now the next step is to explore all the its neighbors. So one is directly connected with the 6, one is directly connected with 8, and we can see the one is directly connected with 5 and 9. Since this is the source vertex, and we have explored all its neighbors that are 6, 8, 5 and 9. Let's enqueue them in the queue. It's not necessary to write the numbers or the vertices in the ascending or descending orders. You can write them randomly as well, so it becomes 6, 8, 5, 9. Once you have visited all the vertices, you can mark them with the T sign and the source can be dequeued. Fine. At the same time, you will construct the new tree and you will add the source vertex with its neighbors. So let me do that over here. So you can see one was connected with 6, 8, 5 and then 9. Now the new source vertex will become 6 in this case. Okay. So this is our new vertex or the source vertex. Let's explore its neighbors that are one which is already visited. So we will not enqueue it. The next neighbor of the 6 is 5. It has been explored as well, so we will not enqueue it. The next vertex or the vertices that are basically 7 and 2. Let's enqueue them in the new queue. So in this way, they will be enqueued in the new queue, and we will also add the two edges between the new graph starting from 6 ending at 2 and the edge between 6 and 7 in the graph. So let's do it over here that we were constructing. So there was an edge between 6 and 2 and 6 and 7. So in this way, we will keep constructing the new tree as well. Once we have explored all the vertices of the source vertex, which was 6 in this case, we will move to the new source, which is 8 now in this case, and we will explore its neighbors now. Fine. And we will construct the new queue like that. So you had 8, 5, 9, 2, and 7. And the neighbors of 8 are the neighbors of 8 are 1, which has been explored already, so we will not enqueue it. And the next neighbor is 7. It has also explored, has also been explored, and the last neighbor, which is 4 in this case, it's not explored. So we will enqueue it. Fine. And also we will add an edge between 8 and 4 in the new graph. So here we will add an edge between 8 and 4 in this case. Fine. And now we will actually dequeue 8. Why? Because we have visited its neighbors. The new queue will be, so this will be our new queue, and now the source vertex becomes 5 in this case. Fine. So this is our source vertex at the moment. The neighbors of 5 are 1 already visited, 6 already visited, 2 which has been explored already, and then 4 which has also been explored already. So we will basically add no element in the queue because its no neighbor is supposed to be visited now. Every neighbor is actually explored. So we will dequeue 5 from the queue. Okay, the new queue will be right now this one, and the source vertex becomes 9 in this case. So this is our current source, and you can see its neighbors are 1 which is has been explored, and similarly 4 which has been explored already. So we will dequeue it, and there is no need to add the new element in the queue. The new updated queue after the dequeue operation will be, so this will be our new queue 2, 7 and 4. The source vertex becomes 2 right now. So let's see what are the neighbors of the 2. So 6 already explored. Fine. 5 already explored. 7 already explored. All right. So we will actually dequeue it only, just like I did over here. Now the source vertex becomes 7 in this case. Fine. So here we will have basically 7 as the source vertex, and let's explore its neighbors. The neighbors of 7 are basically 6 already explored, then 2 already explored, 8 already explored, and you can see this neighbor, which is actually 3, has not been explored yet. So basically what we will do, we will enqueue it at the tail, and also we will add the edge between 7 and 3 in our new graph. So let's just do it now. So here you can see I'm going to add the edge between 7 and 3. Fine. And we will dequeue it from the queue. The last, so now we will have the queue containing the elements 4 and 3, and you can see the source vertex becomes 4 in this case. Fine. And in this graph, it is very clear that all the vertices have been visited now. So explored, explored, explored and explored. We will just perform the dequeue operation, and we will remove it from the queue. The last element that is left is 3 now in this case, and let's explore its neighbors. It's clear that the neighbors of 3 have been explored as well, 4 and 7. So we will just perform the dequeue operation again, and we will remove it from the queue. Now the queue is empty, and here your algorithm will stop. And ultimately the breadth first search algorithm will give you the tree head, and you can see the different levels over here. So this is marked as level 0. This will be marked as level 1, level 2, and finally the level 3. All right, and here you can find the spanning tree, and you can visit all the vertices starting from this source vertex, which is 1 in this case. Thank you for watching.